In this video, we're going to talk about how to find probabilities for a normal distribution using a TI-84 calculator. In order to access our distribution menu, we're going to press second and vars. Second and vars. And you'll notice it takes us to the distribution menu, and you'll notice there are two normal functions, normal PDF and normal CDF. We will never use option 1. We're always going to use normal CDF option 2. And when I go to normal CDF, it asks me for 4 values. So it asks me for the lower bound of the shaded area, and then it asks me for the upper bound of the shaded area. It asks me for the mean of my distribution and the standard deviation of my distribution. In order to get that lower and upper bound correct, it is important that we draw a properly labeled normal curve and mark the area of interest. We're going to do some examples so you can see what this looks like. So, example, the distribution of weights of golden hamsters is approximately normal with a mean of 200 grams and a standard deviation of 28 grams. What is the probability that a randomly selected golden hamster will weigh less than 175 grams? So probability that X is less than 175. So I'm writing my probability notation. And with the TI-84, I don't have to convert to z-scores. I'm going to label my picture and use my calculator. So I know I'm using raw data. I know the middle is 200. And then it's going to be 228. And then I can't do math in my head. So 28 plus 28. Going to be 256. And then plus 28. 84, so 284. And then same thing in the other direction, so 200 minus 28, 172 minus 28 is 144, and 116. I'm going to come in here and mark where I'm sitting. I'm at 175, which is just above that 1 standard deviation marker. And I want less than, which is to the left. So I want this area here. So I'm going to go second vars, normal CDF. And the question is, what is my lower bound? I can see that the upper edge of my shaded area is 175. Where's the lower edge? And the answer is negative infinity. We know this curve goes forever. Your calculator is going to approximate negative infinity as negative 1e99. And it defaults to that. It defaults to a left-tailed picture. If you need to type this, 2 notes. 1, negative is this button, not the subtraction button. And 2, that E is not the letter E. It is not the blue E, green E here. It's this blue double E that stands for engineering notation, and to get it you press second comma. We're going to fill in the rest of our information. So our upper area boundary is 175, our mean is 200, and our standard deviation is 28. We're going to go paste, and it's going to type that, and I'm going to type that as showing my work. So normal CDF. And I like to label my stuff, lower bound, upper bound, mean, standard deviation. And then we're going to press enter to run it, and we get 0.18, and then 596 is going to round up to 60. And I want to double check and make sure that makes sense. So I'm going to scroll up a little bit. So I know I'm sitting right about here, just inside of 1 standard deviation, and I've got 13 plus 2.4 plus a little bit less than 1 is gonna put me at about 18%. So that value that I just found, totally reasonable with what we know about the empirical rule. All right, try another one. So this one says, what is the probability that a randomly selected gold... Oops, sorry about that. I don't know why it decided to do that in the middle of a video. What is the probability that a randomly selected golden hamster will weigh more than 200 grams? So Px is more than 210 grams. And we've got our picture labeled. I'm not going to relabel those numbers. Now that I know where they are, I know 210 is just a little bit above the mean. So 210 is right here. Greater than is going to be this way. And I know that if the lower end's negative 1e99, the upper end is probably positive 1e99. So we're going to set up our normal CDF. So 210, 1e99, 228. Second bars, normal CDF, 210, 1 second, comma, 99, and those two values are the same, and I get 0.36049 is going to round to 5. Question is, does that make sense? And yes, I know I should have a number that's just a little bit under 50, because here's the 50 marker. So I know that I'm in between that 50 marker and something that's a little bit more than 20. So that makes sense that I'm sitting here with what I know about the empirical rule. Last one says, what percentage of golden hamsters weigh between 175 and 225. So 175 is just inside of 1 standard deviation on the lower edge, and 225 is just inside of 1 standard deviation on the upper edge. So already I know my answer is going to be less than 68% because I'm within 1 standard deviation of the mean. I'm going to go ahead and set up my normal CDF. Nope, forgot to shape my curve. So the lower edge is 175, upper edge is 225, mean is 200, standard deviation is 28. And we're going to go ahead and run that on our calculator. And we get 0.6281, which is just a little bit under 68%, which is exactly what the empirical rule tells us. I do want to answer one quick question that will probably come up, which is sometimes they're going to give you a probability and ask you what that boundary value is that you would have used here in your function call. And the answer is, if you go to second bars, you open up that distribution menu, you'll notice the thing right below normal CDF is inverse norm. And what inverse norm does is it takes an area in that picture and it spits out a boundary value. So for example, if I wanted the boundary for a percentage of 30.3605, I would come in here and 0.03605, sorry. Maybe, if I can type today. I would enter my mean of 200, my standard deviation of 28, And this is a right tail, so it indicates right. And I'm going to go to paste. And notice it spits out something that rounds to 210. So inverse norm is the answer to how do I do the reverse, take an area or a probability and spit out a boundary value. All right, if you have any questions on this video, feel free to send me an email or drop by office hours. Otherwise, I'll see you in our next video.